In this video, I will talk about frequency distributions. So we're going to learn how to construct a frequency distribution including limits, midpoints, relative frequencies, cumulative frequencies, and boundaries. We're also going to talk about how to construct frequency histograms, frequency polygons, relative frequency histograms, and ogives. So some of this I will talk about in a separate video, but right now I'm going to talk about frequency distributions. So a frequency distribution is a table that shows classes or intervals of data with the count of the number of entries in each class. The frequency, which we denote by the letter F, of a class is the number of data entries in the class. So if you look over here to the right, I have a frequency distribution, I have my classes, and I have the number of data values that fall within each class. So each class has a lower class limit, and then they also have an upper class limit. So the lower class limit is the least number that can belong to the class, and the upper class, which is the greatest number that can belong to the class. The class width is the distance between lower or upper limits of consecutive classes. The difference between the maximum and minimum data entries are called the range. So if you look at um, this frequency distribution, the class width is the difference between the lower class limits. So if you go from here to here, it's 5. You take 6 minus 1 is 5. You do it again, 11 minus 6 is 5. 16 minus 11 is 5. So when you have a frequency distribution, the class width has to be the same. All the classes have to have the same width. You can also do it with the upper class boundaries. If you took 10 minus 5 here, you'll get 5. If you took 15 minus 10, you'll get 5, and so on. So how do you construct a frequency distribution? Well, most frequency distributions can be done with technology, but I'll show you how to do it by hand so you can understand the concept. So first you're going to decide on the number of classes, and that's usually between 5 and 20. Otherwise, it may be difficult to detect any patterns. Then you're going to find your class width. In order to find your class width, you're going to take your smallest number in your data set, and you're going to subtract it from your largest number. That's the range. Okay? So you're going to take the max minus the min, and then you're going to divide that by the number of classes that you want. So you might end up with a decimal, but you round up to the next convenient number. Once you do that, you're going to find your class limits. You can use the minimum data entry, the smallest data value in your set, as the lower limit of the first class. And to figure out the remaining lower limits, all you have to do is add the class width to it. To find the upper limit of the first class, you'll do the same thing, and I'll show you when I do an example. The upper limit of the first class is usually 1 below the lower limit of the next class. So I know that sounds confusing, but you'll see in a few minutes. And remember, your classes cannot overlap. And then you'll find the remaining upper class limits. Then you're going to make a tally mark for each data entry in the row of the appropriate class. And then you count the tally marks to find the total frequency of each class. So let's go through a problem. It says this data set lists the out-of-pocket prescription medicine expenses in dollars for 30 U.S. adults in a recent year. And we're going to construct a frequency distribution that has 7 classes. So this problem tells us how many classes we should have. So this is the data set. So one person paid $405 out of pocket for prescription medicine. Somebody else paid $290. So that's what these numbers mean, how much they paid out of pocket for prescription medicine expenses. So we know in the problem it told us that we want 7 classes. So to figure out the class width, I'm going to take the maximum number, which is 405, and we're going to subtract off the smallest number in the data set, which is 155. I'm going to divide that by 7, and as you can see, I get 35.71. So I'm just going to round that up to 36. That's got a whole number, is easy to work with. The next thing I'm going to do is I'm going to use the smallest data value, which is 155. I'm going to use that as the lower limit of my first class. Okay? So what I can do is, I know that the class width is 36. I can add 36 to that 155 and that'll give me 191. And I just keep going. I keep adding 36. When I add 36 to 191, that gives me 227. And I keep going until I have 7 classes. As you can see, I have 7 lower limits. To figure out the upper limits, what I'll do is you're going to take one less than the lower limit of the next class. So I know this lower limit is 191, so that means my upper limit here must be 190. You just go one back. Okay? And as you can see, this lower limit is 227, so that means this upper limit is 226. But now that you have a couple of the upper limits, you can add 36 to the which is the class width. So if I keep adding 36, if I add 36 to 226, that gives me 262. Add 36 to that, that gives me 298, and so on. So now I have all of my upper limits. So basically I have my classes. And now what you do is you're going to go through the data set and you're going to determine which data values fall within each class. So if you look at this first class, 155 to 190, I have 3 tally marks because 3 data values fall within that class. So if we go back to the data set, I know 155 falls in there, 165, and we got a 168. Those are all the data values that fall within the first class. If you look at the second class, I have 2 tally marks. So that means 2 numbers fall between 191 and 226. So if I go back to my data set, I have, let's see, I should have 195 and should be another one, 200. Those 2 values fall within 191 to 226 class. And you just keep going. So as you can see, I have my frequencies over here to the right. And your frequency should add up to the number of data values that you have. So we had a total of 30 data values, and that's what this frequency column will add up to. It should add up to 30. So now that we know how to determine the frequency distribution, we're going to calculate some other things. We're going to calculate the midpoint. The midpoint is the lower class limit plus your upper class limit divided by 2. So if we go back to that first class, and I'm actually going to do a whole one for you. The class went from 155 to 190. We're going to add those 2 numbers together and divide it by 2. We get 172.5. That's the midpoint of the first class. That's the middle of that first class. We can, since we already know the class width, we can just add 36 to the next midpoint. So if I take 172.5 and add 36, I get 208.5. That is the middle of the second class. And I'm going to show you a whole problem on that. Next, we're going to talk about relative frequency of a class. And that's the percentage of the data that falls in a particular class. So what you'll do is you're going to take the class frequency, the number that falls within that class, and divide it by your sample size. And that's N, the total number of data values that you have. Okay. And then the cumulative frequency is the sum of the frequency for that class and all the previous classes. The cumulative frequency of the last class is equal to the sample size n. So we're going to use the frequency distribution in the previous example. We're going to find the midpoint, the relative frequency, and the cumulative frequency of each class and describe any patterns. So I'm going to do the first 5 classes, and then I'll show you the expanded version of it. Alright, so the first thing we're going to calculate is the midpoint, and I already told you how to do the midpoint. So if we do this first class, it's 155 plus 190. We're going to divide that by 2, and I get 172.5. When I do it for the next one, I take 191 plus 226 divided by 2. We get 208.5. Now, as I said in the previous slide, we already know that the class width is 36. So I don't have to go through and add the lower and the upper and divide by 2. What I can do is I can just now take 36 and add it to each one of these midpoints. So like I said, 172.5 is the middle of the first class. 208.5 is the middle of the second class. So I'm going to add 35 to each one of these class limits to figure out the midpoints for the remaining classes. So all I'm doing is the first 5. So those are the midpoints. Now we're going to talk about relative frequency. We know that we had a total of 30 data values in this set. So the relative frequency, or the percentage of values that fall within this first class, is going to be calculated as 3. We're going to take the frequency and we're going to divide it by 30. I get 0.1. I do the same for the next one. I'll take 2 divided by 30. I get 0.07. I keep going. I believe the next one was 5 divided by 30. I get 0.17. 6 divided by 30 gives me 0.2. And then 7 divided by 30 gives me 0.23. Now we're going to talk about cumulative frequency. I'm going to write this a little better. Cumulative frequency is when you take your first value and then it just accumulates. So the first value, the first frequency is 3. So the cumulative frequency for the next one would be 3 plus 2, which is 5. And then we'll take the next one, 3 plus 2 plus the 5. We get 10. And then we'll take 3 plus 2 plus 5 plus 6. We get 16. And then 3 plus 2 plus 5 plus 6 plus the 7 gives me 23. All right. So now this is the expanded frequency distribution below. This shows all the classes. Remember, I only did the first 5 classes. So when you add up your frequency column, you should get 30. When you add up the relative frequency, that should be 1. And if you look at the cumulative frequency, the last data value, or the last number in this set, should be the total number of data values that you have. And we had 30, so the last number should be 30. And from this, we can determine some patterns. So, for instance, the most common range for the expenses is $299 to $334. Because if you look here, this has the highest frequency. So most people paid, out of those 30, 7 people, and that was the majority of the people, paid $299 to $334 out of pocket for prescription expenses. And then we can also see about half of the expenses are less than $299. So if you look here, this is $299. If you count from here to here, you have about 11, 12, 13, 14, 15. You got 16 here, and from here to here, you got 14. So about a little bit more than half paid less than $299. So that's why you use the frequency distribution, because it's better to see your numbers in table rather than just looking at a big old data set. So if you go back to the data set, you're not going to be able to determine any patterns. But if you put it in tables, charts, graphs, then you're better able to see some type of pattern.